Hey everyone, it's Justin again. Today, we get to take everything we've learned in our unit and use it to sketch graphs of rational functions. By the end of this lesson, you should be able to sketch graphs of rational functions. First, we'll make a table summarizing how to find all the attributes of rational functions that we've learned about, including the discontinuities, asymptotes, and intercepts. Then, we'll complete 2 examples. We're going to start by creating a table summarizing all of the attributes of rational functions that we've learned about in this unit. Our table has 3 columns, as shown here. The first attribute we learned about was the vertical asymptote. We want to summarize in the shortest way possible how we can remember how to find the vertical asymptote, or vertical asymptotes if there's more than one. That will go in our rule column. And we want to know what the best form of the equation to use is, as in, is the factored form the best or the unfactored form? Pause the video here and go back in your notes to figure out how you would summarize the rule for finding the vertical asymptotes in a rational function. Okay. You may have said something about factoring the equation and looking in the denominator for factors that don't cancel, then setting them equal to 0 and solving. That's exactly what we have here, as shortened as I could possibly think of to make it. This table is going to get kind of long, so we want to summarize everything we've learned in as few words as possible. And I have a big assignment for you. This will take some time. I want you to go back in your notes and summarize all of these other attributes in your own way so that you will remember them. The only one you're not really familiar with right now is the last row that says additional points. So you can leave that one blank for now. So pause the video now to make your own table like this and summarize how you will remember how to find each of these. Let's go through my summary and compare it to yours. For the wholes, I said that we have to look at the denominator of the factored form and solve the factors that do end up canceling. For the horizontal or oblique asymptotes, I remembered that we used the unfactored form of the equation and look for the highest degrees in the numerator and denominator. We also have 3 possible cases here. The first case is when the degree of the numerator is less than the degree of the denominator, and our horizontal asymptote is y equals 0. Case 2 is when the numerator and denominator have the same degree, and the horizontal asymptote is then the ratio of the leading coefficients. And finally, the third case is when the numerator has a degree 1 higher than the denominator, and then we must use long division to find an oblique asymptote. Next up is the X Intercepts, and we get those from finding the factors in the numerator that don't cancel, setting them equal to 0 and solving. For this, we need the factored form. Then we can find the Y-intercept. I remember really liking this one because we could just use the unfactored form and cross out all the terms with X to see what was left over to find this. The other thing we'll have to do to help us graph is find any more points that we feel will help us make the graph more accurate. This may include finding the y value of the hole, if we have a hole, and any other points that alleviate any confusion we have when we're graphing. I'll explain this part as we go through the first example, so don't worry about this attribute for now, but definitely add it to your notes while you have a chance. Before we move on to 2 examples, that was a great time to stop and reflect. Did your table look a lot like mine? Did you make some changes after seeing what I put in my table? I want your table to work for you, so if you need to change or finalize anything, or even just read through it one more time, go ahead and do that. Also, this table is really big, and I won't have room to bring it up on the screen every time I refer to it, so your notes need to be awesome. So pause here and take care of any of these things now. Okay, it's time to start our first example. we'll need to find all the attributes listed in our table to help us sketch this graph. Some of them will require the factored form, so we may as well find that first. So pause here and factor this function. Now that we have the factored form, let's start going through our table of attributes and find all of them. We found all these attributes before in previous lessons, so it's a really good time to see how much of this you can do by yourself. Now, pause the video and try to find any vertical asymptotes, holes, horizontal or oblique asymptotes, and intercepts all by yourself. Okay, let's check your work. For the vertical asymptotes, we use the factored form of the equation. The only factor that doesn't cancel from the denominator is x minus 2. So setting this equal to 0 and solving gives us a vertical asymptote at x equals 2. For any holes, we use the factor that did cancel from the denominator. Setting this equal to 0 and solving gives us a hole at x equals negative 4. When writing this, we can leave a space so we can go back and find this point's y value later. Now let's find the horizontal or oblique asymptote. Looking at our unfactored form, we can see that the numerator is 1 degree higher than the denominator. This means we do not have a horizontal asymptote, and we have to use long division to find an oblique asymptote. Remember, we don't really have to finish the long division here and find the remainder. Once we get our linear expression of x minus 1, we can stop. So let's add this asymptote to our list. How are you doing so far? If your work from earlier isn't matching mine, you can pause any time you need to investigate further. All right, time to find any x intercepts. In our factored form, we have two factors that don't cancel in the numerator, x and x minus 3. Setting those factors equal to 0 and solving gives us two x intercepts. For the y-intercept, we cancel all terms with x in our unfactored form and are left with 0 over negative 8, which is 0. So when we make x equal 0, y also equals 0. Adding this to our list gives us almost everything we need to graph this. The final row on our attribute table said to find any additional points that will help us sketch the graph. If we do need to find extra points to help us graph it, most of the time it'll be when we're in the process of making the graph, which we'll do shortly. But if we have a hole in the graph, we already know we'll need to find that point. So we can do this part now. Remember that we said x plus 4 canceled, and that's why we have a hole. So let's see what the y value would be when x is negative 4 in the simplified equation. Let's take this simplified form and substitute negative 4 in anywhere we see x. Pause the video here and calculate the output, or the y value. This simplifies to be negative 14 over 3. We can include this in our list and complete the point for this function's hole. So, here we have it. Everything we need to graph the function, besides any extra points that may be helpful. But we'll see if anything extra is needed when we start graphing. Oh, and also, if you don't have graph paper at home, you could just search for some on the internet and print some. You can also just use regular paper and a ruler if you need to. I am so excited. The time has come, and we get to finally make our own graph. Man, we have worked so hard to get to this point. I know you can do this. Pause the video and try it on your own. I will wait here in anticipation. Okay, my turn to try. I'll start by drawing the vertical asymptote at x equals 2. Then, I'll draw the hole at negative 4 and as close to negative 14 over 3, or about negative 4.7, as I can get. Now, I'll draw that oblique asymptote. And here are my x intercepts. My y-intercept was the same as one of my x-intercepts, so I already drew that. So what do you think of my sketch so far? We're definitely getting somewhere. And now we need to sketch in our curves for our graph. The part of the graph farthest to the right has 2 asymptotes to follow. So I'll sketch that in. Remember, your sketch does not need to be perfect. Might start to get a little bumpy too. Then we have another pretty good guide to help us draw in the rest. Oh, look what we made here. Oh, it's awesome how much we've learned. If we type this equation into a calculator to check our work, our sketch wouldn't be perfect, but that's why it's just called a sketch. We have one more example today. Which of the following is the graph of the rational function below? For a problem like this, it's best for us to just sketch it ourselves in the same way that we did in the previous example. Then we can compare our sketch to the answer options. We definitely need the factored form of this function so we can find all the attributes. So go ahead and try this problem by yourself again. Hopefully you can get even further than you did on your own in the last problem. Maybe you can even sketch that entire graph by yourself. So pause the video here, give it a try. Here is our factored form. We can find any vertical asymptotes from factors that don't cancel in the denominator. We find holes from factors that do cancel in the denominator. And since there isn't anything to cancel, there are no holes. That's kind of nice because we won't have to go back and find the y value of a hole later. We can see if there's a horizontal or oblique asymptote by comparing the degrees. Since the denominator has the larger degree, we have a horizontal asymptote of y equals 0. Next, we find any X intercepts. The factor that didn't cancel in the numerator is x plus 3. So we have an X intercept at -3. Our y-intercept can be found by canceling terms with x in the unfactored form. This will give us positive 3 over negative 10, which is negative 0.3. We have everything we need so far, so let's try sketching that graph. Pause here if you need some time to finish up, and try sketching the graph yourself. Let's get those vertical asymptotes on there at -5 and 2. Then we can sketch our horizontal asymptote at y equals 0. The x-intercept is at -3, and the y-intercept is at negative 0.3. That's all the information we have. This looks a little tougher to sketch. I'm unsure whether to sketch above or below the horizontal asymptote here, so we'll have to find a point on the graph to know for sure. Remember that last row you wrote on your attribute table? Well, here it is in action. What x value bigger than 2 wouldn't be so bad to work with? Well, any whole number would be fine, so let's just try x equals 3. Substitute 3 in everywhere you see x in the factored form of the function, and what do you get? This will give us 6 over 8, which simplifies to 3/4. Let's plot that point, 3, 3/4. Now we know that our sketch must go above the horizontal asymptote here, so we can sketch it in. Let's work in the section between -5 and 2 next. We know our graph can't do anything like this since there's only one x-intercept on this part of the graph. We know that it only touches the x-axis once. But the graph could come from above and go downward, or it could come from below and just touch the x-axis before turning around again. Since we want to see if it comes from above or below, let's try x equals -4 and see what our y value is. Here we go again. -4 plus 3 over -4 plus 5 times -4 minus 2. See if you can take it from here and find the y value when x is -4. Then decide what the graph should look like in the middle section and see if you can finish graphing the last section on the left too. All right, let's finish up together. When substituting -4 for x, it gives us an output of 1/6. So let's graph the point -4, 1/6. Our graph does go above the x-axis on the left, so let's sketch it in. We have one more section on the far left where x is less than -5. Does the graph go above the horizontal asymptote or below it? Did you find a point? Or can you do that now? If we substitute -6 in here for x, we'll get an output of -3/8. When we graph -6, -3/8, we can see that the graph is below the horizontal asymptote. We sketch that in the best we can, and we've done it. It feels great to have come so far. We've learned so much. We just did a lot of work, but we haven't answered the original question. We had 3 graphs to choose from in our original question. Are you ready to pick the right one? Do you have your sketch finished? Compare your sketch to these 3. Which one looks like what we just made? Oh, yeah, it's the first one. So that's our correct answer. Some of the questions in the practice for this lesson will look like this, and you will need to select the correct graph from a PDF called Rational Function Sketches. You will definitely need that for the practice, so make sure you have it ready. Now you can graph rational functions from an equation. Don't forget to keep your organized table handy in case you need it again. And remember to find the Rational Function Sketches PDF for the practice. And life advice, if you ever take college math classes, you'll want to still have this table. See you next time.